So I want to show you two more properties of limits of functions that should not surprise you at all. So the first one is that if you have the limit as x goes to a of f of x all to the nth power, then this is equal to the limit as x goes to a of f of x all to the nth power. You can pass the limit inside the power, and we'll see an example of doing that in just a minute. It's basically just the product rule applied n times. Now, I didn't write it down, but for this rule to hold, you need to know that this inside limit actually exists. Okay, so on a similar note, if you have the limit as x goes to a of the nth root of a function, then you can write this as the nth root of the limit of the function. And so I think these rules are best learned via example. So let's just do one. So here I want to look at the first one, and I'm taking the limit as x goes to 2 of the square root of x to the fourth minus 12. Immediately, by the previous property of limits, I can write this as the square root of the limit as x goes to 2 of x to the fourth minus 12. And so now I'm focusing strictly on this limit, but this function is a polynomial, and we know that polynomials always satisfy the direct substitution property, and so I can plug in 2. I get 2 to the fourth is 16 minus 12 is 4, and so this is exactly the square root of 4, which is just 2. So that one worked out nicely. This second example, sine of x is a trig function, and we know that trig functions have the direct substitution property as long as the point that you're taking the limit at is in the domain of the function. Well, sine of x has domain everything, and so you can simply plug in 0, and you get that this limit is the sine of 0, which is 0. And the last example that I want to do with you, I want to study a piecewise defined function. So this function g of x is the line 3x plus 2 whenever x is not 2, and then it's root 10 whenever x is 2. And I want you to realize that this g of x is equal to 3x plus 2. It's the same as the function 3x plus 2, except at a single point, at the point 2. And so by the property, I'm going to scroll up here to show you, by this previous fact that we talk about, if two functions agree everywhere except at a, then their limit at a is the same. And so we're going to scroll down and use that here. So when I go to compute the limit as x goes to 2 of g of x, I know that this is actually the limit as x goes to 2 of 3x plus 2, because 3x plus 2 and g of x are the same function except at 2. And so now I can simply plug in 2. This is a polynomial. I can use the direct substitution property, and of course I get out 8. And for the record, just to help you see this, you can actually graph g of x if you want to. And I'm going to do a real quick graph. So y-intercept of 2, actually it's not going to be to scale, so something like that. And if you go over here to 2, there's going to be a hole. There's a hole sitting there at 2. And it turns out that the root 10 is below the line. So the g of x looks like this. And when you look at it that way, it's pretty easy to see what's going on. Okay, even though g of 2 is not 10, right? g of 2 is not 8. g of 2 is in fact root 10. But you can see that the limit as x goes to 2 of g of x is getting closer and closer and closer to this y value, which is 8. So let's end this video here, and I want to do more examples in the next video. We're going to do a lot of examples in this section. Hopefully they'll help you understand the concepts.